So the purpose of the worksheets is that we are now going to get into working with equations more so than, say, graphs. Now, any of the calculus ideas that we talk about have to apply to functions as graphs, functions as tables, functions as equations. Those are the main ways you get functions. And when you look at the title of your book, it is calculus from a graphical, numerical, and symbolic point of view. Graphical is what we focused on in chapter 1. Numerical would be like tables of values. And symbolic would be like that, math symbols, right? Algebraic equation kind of thing. So all the math calculus concepts we learned are going to apply to functions, okay? But it'll look different depending on what the function looks like. So this book, and I really like how they do it, all the new topics they approach graphically first. So everything we did, the quiz we just took yesterday, which we're not going to hand back, by the way, because I got about 4 people that still have to make it up. And kind of my rule is we won't go over the quizzes until everybody's taken them. So, but the grades are, did you notice the grades are up? So you can see how you did. So we look at it from a graphical point of view, which is visual, and we can kind of get the concepts of what's going on. And then we move into the symbolic, the equation versions, keeping in mind all those concepts we've still learned with the chart and everything, but then applying them to equations. Okay? So we have to be able to work with equations. We have to be able to solve equations, because one of the very first things, if I give you an f prime graph, if I give you an f prime graph like this and ask you some questions about f, what's the first place you look on this graph right here? And I started asking, where does f have, say, a local max or min, maybe, or something like that? Right? There. Right? You look at where f prime is equal to 0. Well, what we're going to learn now in this chapter is if I give you f prime as an equation, or better yet, if I give you f as an equation, we're going to find the f prime equation, and then we're going to set it equal to 0, and we're going to solve it, right? So, and you've heard me say this before, a lot of times this year, I'm going to say to you, if you don't know what to do the derivative and set it equal to 0. Do the derivative and set it equal to 0 and solve it. And that'll give you stationary points, and then something good typically happens from there. Okay, so we need to be able to solve equations. All right, so anyway, up here was just some typical algebra, and I've got the answer key. I worked out the answer key to this one, so you're free to look at that later. But how do we do it on the calculator? So if we go to the calculator and do a solve, read that to me. Let me get my solve up here. So I really intended for you on the bottom section here to just type it into your calculator. Okay, so read the equation to me. Max, go ahead.
5 cosine squared.
Okay, now to do cosine squared, you can't put the squared like we do there. What's inside of there? 3x
plus 1.
3x plus 1. To type in cosine squared, you have to put the squared outside here, like that. Now, if I wanted to square just the 3x plus 1, then I'd have to put that in another set of parentheses. I wasn't sure if this squares the cosine. I could put an extra parenthesis in there just to be sure, so I could put like a left parenthesis. So I got this left parenthesis, except it put it in the wrong place there. Let me get rid of that squared. If I was really going to be careful about this, I would probably put the squared there, okay, because it's the cosine of 3x plus 1 that I want to square. Never, ever forget that when you have this shortcut notation, when you have this, we a lot of times say sine squared x, but what this really means, and this is going to be really important for us later on, that really means that. So it's very important you understand that. This is just lazy shortcut notation that we all use, but what it really means is this. Okay, so it's very important to understand it. All right, so anyway, but the 5's not squared. Okay, so keep going. Then what?
Equals -2 cosine 3x plus 1 plus 1.
and then the plus 1's outside that parenthesis. Okay, so there's my equation. I have to put comma x, and then I showed you this maybe one time. Do you remember what do you have to put outside of this to limit it from 0 to 2 pi? I meant to talk about this yesterday, but we were kind of working right up to the end of the bell, so I didn't get a chance to do this. So this applies to number 5, number 6, number 7, number 8. If I hit enter right now, I'm going to get some really crazy looking stuff. Was that kind of your question then? What do I do with this? Now, the first thing I would do then is hit control enter, so I get decimals. But then you get this n3 pi thing. Well, remember the plus 2n pi, stuff you get with trig? Because there's infinite number of answers. So here's what we really want to do instead. When I type this in, I want to go out to the very end of the solve. I want to go out to the very end of the solve, outside of all the parentheses, and I need to tell it to limit it from 0 to 2 pi. Now this happens in trig equations especially. Okay, so what I need is a vertical bar, which I get here in the equal sign, control equals, and there's this vertical bar right here. Now this is not an absolute value bar, it's a different thing. It's a vertical bar that says with or such that. What I'm telling it is that I want to solve this equation with the stipulation that x is between 0 and 2 pi. So I put in 0, then I get this less than or equal to, then I get x, then I get less than or equal to again, and then I put 2 pi like that. And now I'm telling the calculator to solve this, but I want the stipulation that I'm only going to look between 0 and 2 pi. Now I'm going to hit control enter so I get decimals. I force it to give me decimals, and now I get a whole bunch of answers. I think I wrote down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 answers. There were 12 answers, okay, to that. And if you just scroll to the right, oops, put your cursor up in there, and if you just scroll to the right, so I just wrote them all down, remember, 3 decimal places, and so I just scrolled and scrolled and scrolled, and that's what I found, okay? That's not going to happen very often where we're going to get that many answers, okay? That's something you will have to do probably on our next quiz, is you're going to have to solve, because we're going to have some trig. There'll be some trig in our next quiz, next 2 quizzes for sure, and we'll be using equations, and we're going to be solving. We're going to do some without a calculator, so like the first 4, and then there's going to be some with a calculator where you do it like this. And so you just got to be able to use this solve. And usually with the trig, because trig equations a lot of times have infinite numbers of answers, okay, we usually limit it. And so we need to be able to do that vertical bar thing. Okay? All right. So, I lied. We don't have time for another question. But hang on to those worksheets. We'll pull them up another time. But it might be a thing where you might have to get some, ask some questions from me individually. All right, go ahead and get your notes out because we do have a short period today. So we want to get through this stuff we need to. All right, so starting chapter 2. Now that's chapter 2, so if you're gone, of course you guys aren't gone, but this video today now I will put inside of the chapter 2 folder on the website, right? So yesterday's, or not yesterday's, but the stuff we've had in the past in the chapter 1, we're now into chapter 2. All right, so very important that we understand the distinction between these two things. So average rate of change, this is an algebra 1 concept. It is the slope between 2 points. It's the slope of a secant line. If you had a curve and you plotted 2 points on that curve and you do the slope, that's called a secant line when it crosses at 2 points. You learned that geometry when you were talking about circles. And the way you do that is the old slope formula. It's got a fancy name called the difference quotient. Kind of makes sense. You're subtracting, so therefore the word difference, and then you're dividing. Therefore the word quotient. So we call that the difference quotient. It's an important idea. It's slope between 2 points, but it's also a rate of change. But it's average rate of change. So in this class from here on out, if you ever get a question where they say find the average rate of change, don't think of the word average as adding up and dividing, right? Like, oh, how do you find the average? Well, you add up 6 things and you divide by 6, and that's how you get the average. That's not what we're talking about. Average rate of change, you're going to hear me say this over and over. When you hear the words average rate of change, that means slope between 2 points. Slope between 2 points. The average rate of change between here and here is the slope between those 2 points. Okay? So it's that formula right there. Now, I want you to think of it this way, not y2 minus y1, but excuse me. So it is the y values, but we want to think functionally. So it's f of b minus f of a over b minus a. Difference quotient. Now, instantaneous rate of change. Of course, we've now learned that means slope at 1 point. The instantaneous rate of change is slope at 1 point. That's a tangent line to the curve. It only touches a curve at 1 point. But we don't have a fancy formula for how to do the slope at 1 point. What we've done is just pick 2 points really close together, right? Pick 2 points, but make them really, really be close together. So we're really just doing a secant line. It's not really a tangent line, but we get them so close together, 0.0000001, right? We get them so close together that we pretty much can tell that that's a slope at that line. Okay, so that's what we're going to investigate today. Now, in your book on page 81, there is a little bit of a problem here that we focus on. Now you notice over here on my goals here, it says we're going to be finding derivatives using the limit definition. We're going to literally define the derivative today. We're going to come up with a definition that is one of maybe the 2 most important definitions that we have all year long. Okay? A very fundamental concept of what the derivative really is. I think we already have an understanding of what it is. It's the slope of the tangent line. It's slope at 1 point. That's what the derivative is. If I ask you on a quiz, just in your own words, what's a derivative? Slope at 1 point. Slope of the tangent line to a curve. Instantaneous rate of change, right? Those would all be things that would say that. So they have this problem about this Professor X that's driving along. And so at the bottom of page 81, there's some information about their miles. So it's kind of like the Bismarck problem. At 1 hour was here, at 2 hours was here, at 3 hours was here, and so forth, so on. So we know a bunch of those things. So what if I wanted to do d prime of 2? So just look at the table at the bottom of page 81. What would you tell me to do? If I'd asked you, if this had been on yesterday's quiz, and I said, find d prime of 2, what would you do? Okay. I think that's way more work than you would need to do.
Pick 2 points.
I think we just do this with 2 really close points, right? Now, we haven't done a lot of work with tables, so that's why I didn't put that on there. So what 2 points, Emily, would you pick?
2 and 80, and then like 2.0001.
Well, now, but how can you pick 2.000001? How would you get the y value for 2.00001? Yeah, there's no equation, right? There's no equation to plug it into, so I couldn't pick 2.000. And I'd like to. So the best I can do is 2.05, right? Now, some people might say it'd be smarter to pick the 1.95 and the 2.05, right? Pick one before and one after, right? Might be more accurate. But I like what you said. That'd be fine. And here's how I would do it. I would actually, it's usually f of b minus f of a. It doesn't matter which way we subtract them, but I would probably do it this way just out of habit. So I would probably do that. Okay? Matter of fact, that's absolutely what you should do. Now, if you want to pick 1.95 and 2.05 as your 2 points, that'd be fine too. Okay? But you wouldn't want to pick any farther away from that. You want to pick 2 close points. Well, those are the closest points to 2 we got. Right? And so all I would do is this right here. Right? I would do a difference quotient. So on our next quiz, very likely you'll have something like that. If you got a table of values, that's the best you can do. That's the best you can do for d prime of 2. That's the best we can do if all we have is a table of values. Okay, so we would do 80, or no, that's 83, excuse me, 83.54 minus 80, and this would be a calculator problem, divided by 0.05, right? So go ahead and do that. You guys get your calculators out and do that for me. So that'd be 3.54 divided by 0.05, and this would be a lot like we talked about where I would say show your problem setup. So I'd want to see at least this line. I'd want to see at least this. The rest of it you can just do on your calculator, but I'd want to see at least that. What do you get?
70.8.
That's it? Or did you round that?
That's it.
It's just 70.8 exactly. Now what would the units be on that? Miles per hour, right? Because it's a rate of change. We took miles, the top number is miles, and the bottom number is hours. So it'd be miles per hour, right? It's a rate of change. Okay, so there's nothing new there, right? I'm a little nervous here that you seem a little confused by that. But all that is 2 points. We did the slope, right? We just did 2 close points, but we can't do 2.01. Does that make sense? Because we have nowhere to plug it, right? Same thing when we had a graph. If I gave you a graph of D, you would have just been able to sketch a line and do a triangle, right? Because you can't plug in a number into a graph, right? It's like a little number. I mean, you can maybe read some numbers off of a graph, but not a lot of them. Okay, so that's the best we could do. Okay, so now the question is, could we do better though? If we had more information, like if we had an equation. So we turn the page, and I don't think they show the equation there yet, but they talk a lot about stuff we've already talked about. They talk about, okay, what if, we pick 2 really close points, and it's kind of like zooming in. We already talked about that. Okay, so remember when we did this with sine? Now, you don't need to write this down, but remember when we did this with the sine graph? And I had several of you do some slope calculations, right, really close to some different numbers. Okay, and then when we plotted those slopes, what did we get? We got the cosine graph. Remember that? Okay, now, I just had you guys do a few, and then we plotted them, and then we kind of guessed, and we said, oh, that looks like cosine. Well, I want to show you something that's a little cool, kind of cool. I went ahead and on your calculator, there's a spreadsheet document. Like I just went to here and went to new, and I grabbed a spreadsheet, okay, page. So let me get out of that. Oops. What was that? What happened to the one I was just on? Oh, shoot. I lost it. Okay, here it is. Put that back up. Okay, so I did a spreadsheet. Now, what did I put in these points? Okay, here I put, here I put pi 8s. I started with 0, then I did pi 8s. If I scroll down here, then I did 2 pi 8s, which is pi 4s. I did 3 pi 8s, and I did 4 pi 8s, 5 pi 8s, right? I went all the way to 2 pi. So I just did a bunch of values, right? All the way around to 16 pi 8. So I got like 16, 17 points here, okay? And so in this column, then I did the sine of that, right? So I did the sine of 0, and the sine of pi 8s, and the sine. Okay, now, what's neat about this, and over here I did a graph page, a data page it's called, where it takes those points. Well, these are all just random points. So I want to plot my x on this axis. I kind of like watching those dots move. And then over here I want to plot my y1. Look at that. Sine graph, right? So all I did was get the sine of a bunch of values, and I got the sine graph. Well, then I wanted to calculate the slopes at all those points. So what I did is I just went over here, and I want you to look at what I typed in there. Does that look like slope? Would that be slope? Right? I just picked 2 really close points. I picked 0, that's my sine of A1, and then I picked a really close point. I just took whatever A1 was and added on 0.001, right? And then divide by A1 plus 0.001 minus A1, right? So that's just those 2 points subtracted together. Does that make sense? Okay, and so then if you've worked with spreadsheets at all, I just grabbed this corner and I just filled it down, right? So now this one is the same thing. So now this is this x value, plus 0.001, did the sine, and then minus sine of that value, and then, right? So that's just the slope formula. So all I did was the slope of 2 close points, but I automated it, right, with a spreadsheet. So all of these values are really close approximations to the slope. Now, what do we think this one probably is? 0.99999. That's just one, right? We talked about that. The sign right there is one. But here's what's really neat about this. I got to use my computer here. So what I can do on this page is now I can plot those on the same graph. So I can go over here and I can right click here and I can add a y variable and I can add in y2. And now I plot the y2 column. So I plot the slopes, the squares then are those slopes. Well, sure enough, it's cosine, right? It's cosine. Okay, so what we want to do then is we want to take that same idea. Okay, we want to take that same idea and we want to apply that to any problem in general. Okay, and so here's what this is going to look like. All right, so whoops, that's not what I want to do. This way. Okay, so you don't need to write this down yet. I'll show you what you want to write down here in a second. So what we want to do is we want to create this for any kind of function. So here's function f, and I've plotted point P. Now what I'd like to do is get the slope of that line right there. Right? That's what I'd like to do. Now it's already telling me what that slope is, but we'd like to find that slope. Okay, so the way I'm going to do it, get rid of that line. Okay, so I need a second point, right? So the only way we have to do slope is to have 2 points, right? So I'm going to pick a second point that's h units away. Now I really want it to be close, right? I want it to be like 0.001, but I'll drag that. I'll just let h get littler, right? So h is the distance between these two. Does everybody understand that? H is the distance between these two. Okay, so now here's my second point. Okay, we'll call it Q. Okay, and then does everybody understand this right here? F of A plus H, that'd be the y value of my second. It'd be like the F of B, right? So what I have here is A and B and F of A and F of B, but instead of calling it B, I'm going to call it A plus H. Kind of like on that spreadsheet, I had A plus 0.001, right? Makes sense? That's my second point. Okay, so now I want the line between those two. That's a secant line, so the slope here would be the average rate of change. So it would just be these y values subtracted and these x values subtracted, right? So all that is this page, right? That's just this right here, right? Slope between 2 points. Okay, so now, so you can see I kind of have that picture drawn over here, and you guys will draw that here in a second. Okay, so what I'd like to do, though, is I'd like for these 2 points to get closer and closer together, right? So I can do that by just grabbing h and dragging it, and I'm going to make h smaller and smaller. So do you see how that line is getting closer and closer to being, it disappears, but it's, right? Because I can't have the 2 points be the same, of course, because what happens to the formula? What happens to this formula if the 2 points are the same? 0 divided by 0, right? That's not good, right? So that's why that line disappeared. Okay, that's why that line disappeared. So I can't have the 2 points be the same. That's why we can't do slope at 1 point, right? Because the formula doesn't work. So we need slope at 2 points, but we can tell that that line is getting really, really close to being the black line, right? The black line is what I'm looking for. The black line is what I want. I want the slope of the black line, but we can tell it's getting really, really close. Closer and closer I get. Look at that. I mean, it's almost the same thing. Right, when I get really close. All right, so, and then I can let this move, right? I can let this move back and forth, but, okay. All right, so, what does this look like? Well, we need what's called the limit. So go ahead and sketch this in your notes if you want here. So what I am doing, I'm going to write down the formula here. So I'm going to write my slope. So that'd be f of a plus h minus f of a all over. Now what would the bottom be? The bottom would be what? I mean, it's rise over run, right? So it's rise, which is those subtracted, and then what's the run? It'd just be h, right? It'd be a plus h minus a. It's just h. So I'm just going to put h down there, right? But understand that that would be a plus h minus a. So it's just going to be h, right? That's the slope between those 2 points, right? But what I want is I want h to get closer and closer to what? No, well, I want a plus h to get closer and closer to A, right? I want A plus H to get closer and closer to A, but I accomplish that by letting H get closer and closer to 0. And here's how we write that. Out in front of this, let me move this one. I write this, L, I, M, and then underneath that, H with an arrow and a 0. We read that the limit as H approaches 0. The limit as H approaches 0. L-I-M stands for limit as H approaches 0. Because if now, what is a limit? We're going to just talk about it informally. They've got a good word here where they talk about a limit here. Roughly speaking, the limit is on page 83. Roughly speaking, the limit describes how a function behaves for x near a specific input value. Near. So, not necessarily when h is 0, because what happens when h is 0? It's undefined, right? So we can't really let h be 0, but we want h to get really, really close to 0, right? We want h to get really, really close to 0. So this is how, with formal mathematical language, we can talk about letting the 2 points get really, really close. And this, by definition, is the derivative at point A. This is what f prime of A is. Now I'm going to put two things in red here. I'm going to say this part is the slope between 2 points, and then this part is the 2 points become 1. Okay, so there's two parts to the limit definition. The definition of the derivative. Remember, the derivative is a slope at 1 point. The derivative is the slope at 1 point. Okay, how do we do the slope at 1 point? We can't do the slope at 1 point. So we have to do it in two parts. We have to do the slope between 2 points, and then we add this guy right here. This is what lets the 2 points become 1 point. We let the distance between them go down to 0. But it doesn't really ever get to be 0. It's what it's approaching. It's a tough concept to grab, this thing. It can't really be 0, but we think about what it would be if it could be 0, right? I mean, that's what the limit is. Okay? And we'll be spending more time talking about the limit as we go through this year. But you just got to think of this second point as moving and getting closer and closer and closer to that point. And your secant line is getting closer and closer to being the tangent line, which is, of course, what we want. That's what the derivative is the slope of the tangent line, the slope at that 1 point. Okay, so how's this going to help us do equations? Okay, well, first of all, I want to do this. Now, you don't have to write this down. You can if you want, but you'll see. We don't really have to write this down. What we're going to do is we're going to, if you've been wanting to do some algebra, right? If you like that part where you get to work out a bunch of x's, kind of like on this equation worksheet, if that's kind of your thing, you like that better than these graph things, then you'll like this stuff, okay? So before we get into it, there's going to come a point we're going to have to understand something here. So if I wanted to do f of 3, what does that mean to you? If this is f of x, what's f of 3 mean? So it'd be 3 cubed minus 2 times 3, like that, right? Well, what's f of a mean? Oops, that'd be cubed, right? A cubed minus 2a. That means put an a in for x, right? What is f of German shorthair? German shorthair cubed minus 2, right? F of German shorthair means put a German shorthair in for x, right? What's f of 2 plus h mean? 2 plus h cubed minus 2 times 2 plus h, right? Everybody with me on that? Okay, so that's it. I mean, that's just notationally, we got to understand what that means. So f of something means put that something into the function in place of the x. All right? Okay, so here we go. This now you want to put in your notes. So let's say this table we had back on page 81, let's say it was actually this function right here. Okay? So this was miles. This function was miles, right? T was in hours. And we want to do d prime of 2. Well, here we go. We're going to use the equation that we've just learned. D prime of 2 is equal to the limit as h approaches 0 of d of 2 plus h minus d of 2 all over h, right? You see where that came from? Let me write this on the board up here. What we wrote down on the other page, we had f prime of a was equal to the limit as h approaches 0 of f of a plus h minus f of a all over h, right? Isn't that what we just wrote on the other page, right? So this time our function is d, so we want d prime at 2, so our 2 is our a, so I put the 2 where the a's at, right? And then the h stays in there, right? And then instead of the function be called f, the function's called d. So everybody see what I did? So I just plugged into this equation we have. All right, now, how do we do this? Well, we're going to recopy the word limit. We're going to copy that on every line. Don't get lazy. Sometimes people get lazy here. Okay? Now, up here now, now this is why I just did this page here a minute ago. Right? Back here I said, what's f of 2 plus h? Plug a 2 plus h into the function, right? So what's d of 2 plus h? 10 times 2 plus h plus 15 2 plus h squared, right? Write that down, right? That's what I got. Okay, now all I've done so far is this part right here. All I've done is part 1 right there. I've taken 2 plus h and plugged it into the d function. And how did I know I should do that? Because I wrote down my definition of the derivative, right? And what did this come from? What was this part right here? What was this fraction? Slope between 2 points. And this part's going to do what? Let the 2 points become 1 point, right? So all of this is just coming from slope. This is all just coming from the slope formula between 2 points. What are my 2 points? 2 and 2 plus h, right? Those are my 2 points. 2 and another point right next to it. H units away. 2 and 2 plus h. Okay, keep going. Now I got to do the second part here. So I got minus. Now here's where people are going to mess this up. Make sure you put parentheses here. What are we minusing? D of 2. What's d of 2 mean? Put a 2 in here, right? So 10 times 2 is 20. 2 squared is 4 times 15 is 60, right? 2 squared, use your calculators. 2 squared is 4 times 15 is 60. So this is 20 plus 60. What is that, 80? So I get 80 for that part. And then all over h. Right? With me? Okay, next line. Yeah, these homework assignments where you got to just write 2 to 7, 3 to 6, right? You know, where's f increasing? Oh, that was nice. That was easy. Okay, now it's going to look more like this, right? Okay, now we get to some real math. All right. So anyway, what's the top look like? Well, let's don't get crazy here. Now, if you want to, well, I'm not going to. So let we distribute here, right? So that's going to be 20 plus 10h plus, now we got to be careful here. I got to FOIL this first. So this would be 15 parenthesis, and then I got to FOIL that. What do you get when you FOIL that? You can't just square those. That'd be 4 plus 4h plus h squared. Now, if you want to go off to the side and have done that ahead of time, you know, whatever, you could have, and then minus 80, and then down here I still have my h. Right? New line. Notice I'm writing this limit every step of the way. Okay, now what do I got? I still got my 20 plus my 10h plus what?
Plus 60.
60 plus 60h plus 15h squared minus 80 all over h. New line. Okay? Yes, this is what you'll be doing on the homework. Anytime it says find d prime of 2 or whatever by the limit definition or by the definition of the derivative, this is what we're saying. Because that's what this is. This is the definition of the derivative. The formal definition of the derivative right here. Okay? So let's keep going. Now what happens here? 20 plus 60 is 80 minus 80. Oh, that's a beautiful thing. That's a beautiful thing. That's going to happen every time. Something nice like that is going to happen. Because, now keep in mind, way back here, remember we said we couldn't let h be 0? We want the 2 points to become 1, but to do that, h becomes 0, but you can't do it because you'd be dividing by 0, right? And it's undefined, so it doesn't work. Watch what happens here now. What's 10h plus 60h? 70h plus 15h squared all over h. I'm running out of room, so I'm not going to go to a new line. I'll just go this way. You could just keep going down. I would probably just keep going down if I could, but I'm out of room. What can I do on the top there? No? Okay, yes. Factor out an h. Okay, but yes, you could, actually, Max, later on this year, that's how I'll think of this. I'll think of this as just splitting this into 2 parts, and then the h is canceled. But for now, I think it's probably better to just think factor out an h, and then cancel that h. Now, this is a key step right here, and this is what's going to be new to you for figuring this out. We now cancel those h's. Now, the problem we had earlier has just disappeared. Remember up here we said we can't let h be 0? We can't let the 2 points become 1 because then the formula doesn't work, right? Because you're dividing by 0. This h down here was a problem because we were dividing by 0. But look what happened. It's gone. Now it's okay to let h be 0. Now we can let the 2 points become 1. So what happens if h is 0? Remember what h was? It's the distance between the 2 points. We want that to get smaller and smaller and smaller and smaller and smaller. So what's going to happen to this 15h term as h gets almost in nothing? It's going to be almost nothing, right? This is going to be 70 plus a tiny, tiny thing. It's going to be 70.00000, right? What do you think the slope is right at 2? 70. Yeah. In other words, it's okay now to just plug a 0 in for h. And we get 70. Remember what we got when we picked 2 really close points earlier? Or the 2 points in the table, remember 2 and 2.05? 70.8, right? 70.8. It was a little too big. That's because it was a little steeper there, right? There you go. And that's equals. That's not an estimate. That's not an estimate of the slope at 2. That is the slope at 2. And mathematically, we've just proven it. So, do we have a special equation for finding the slope at one point? Yeah, there it is right there. And later on, you're going to learn we're going to call that the long way of finding the derivative. We're going to have some shorter ways. You say, well, show me now. I don't want to do the long way. Well, you got to do the long way. You've got to do the long way to grasp this concept. I want you to understand that, look where it came from. It came from slope. It wasn't magic. It came from the slope formula, right? Right there. And then a bunch of algebra. Really, once we got to this point, the plugging in thing, the rest of it was just algebra, right? Algebra. And there we go. Okay, let's do another one. So that was like a related rate problem. Let's do another one, see if we can do it. Okay, so here's just a plain old slope problem. I give you a function f of x, just a basic parabola. You just draw a quick little sketch of it. You don't even have to be honest. You don't even need a graph to be You don't even need that graph. Just write down this function, and I want to find f prime of 2. Now I've already plotted the point. I've put in a nice blue tangent line there. So we're finding the slope of that line, right? That's what we want to know. We want to know the slope of that line right there, okay? So since we have the equation, what could we do? We could plug in our old method, our zooming method. We could plug in a 2 and a 2.001, right? We could plug in a 2 and a 2.001, and we could get a pretty close estimate of what that slope would be, right? But we don't want that right now. We want the actual slope. We want to do it by the definition. So here we go. Limit as h approaches 0. That part never changes. And then what do I write up here? F of 2 plus h minus f of 2 all over h. Now I want you to write that first. I think it's some of you were probably already thinking about plugging the 2 plus h in for the x already. I think you're better off writing the function in f notation or d notation first, writing it out as this, but just taking the a out and putting the 2 in, and now doing the next step. I just think that's easier to do. So the next line will be limit h approaches 0. Now we can do our f of 2 plus h. So we put our 2 plus h in for x. So what do we got? 2 plus h squared plus 2 plus h. So that's the first part. That's part 1. All we did there was plug in our 2 plus h there and there. Then we got our minus sign. And now we want f of 2. What's f of 2? 6. Right? F of 2 is 6. And then we got an h on the bottom.
How do we get the f of 2 to 6?
Well, how do you get f of 2? Plug 2 in for... How do you get f of 2? You plug 2 in for x. How do we get f of 2 plus h? We plug 2 plus h in for x. F of 2 means plug 2 in for x. 2 squared is 4 plus 2. Just plug, yeah. See, don't overthink it, right? That's we get going on. No, f of 2. Remember back here? What's f of 3? F of 3 is you just plug a 3 in for x, right? What's f of 2? You just plug a 2 in for x. So it's 6. Okay? All right, so now we FOIL this out. 2 plus h squared would be 4 plus 4h plus h squared plus, we really don't need those parentheses there because we didn't have anything to mess with. We didn't have a number, if this was 3x, then we'd have had 3 and then parentheses 2 plus h, right? So I didn't really need those parentheses. So now look what happens again. 4 and 2 make 6, take away 6, 6 take away 6, they cancel out. That's a beautiful thing. That's what we wanted to happen. The 4h and the 8, let me write my limit. Sometimes people get lazy and they forget to write this limit every time. We don't really need it until the very end, but if we haven't been writing it, sometimes we forget about it. 4h plus h is 5h plus h squared all over h. We take out an h, or like Max said, hopefully algebraically you could just tell, you could split this into 2, right? It's kind of like having 2/7 plus 3/7. We all know that's 5/7. That's 2 plus 3 over 7. Well, you can go in reverse. If you have 2 plus 3 over 7, you can split it. 2/7 and 3/7. Well, same thing here. We can do 5h over h, which is what? 5. And h squared over h is h. Now, if you don't like that, if you'd rather factor out an h and then make it 5 plus h over h and then cancel the h's, fine. It's the same thing. It's the same thing. Okay? But you're going to get 5 plus h then. 5 plus h there. So factor out an h on top and cancel them, or just think of splitting that up. You can always split apart a numerator over a denominator like this. You can't do it the other way, though. We got to be careful of that. All right. Now remember, that's as h approaches 0. So what's our answer? Our answer is 5. So now, it's easy to get, because remember, now we can just let h become 0. Now that we've canceled out that h, we can let the 2 points become 1, which basically means h becomes 0. When h becomes 0, this is just 5. Now, what if on the quiz I ask you, Oh, you got 5 for the answer. What's that mean? What did we just find? The slope on that graph at 2. Now, if I didn't have this graph here, you'd have to think about that, right? It would be the slope of that graph at 2. That's what I just found. So don't get lost in all that algebra and forget what you were trying to accomplish. We just found the slope at 2. Why? Because that's the slope formula, right? 2 points. But the 2 points are becoming 1. Okay? And that looks reasonable. Looks like that would be the slope at 2. Looks like it would be fine. Okay, so we go back to our very first page, and notice I had this other arrow here. And so slope at 1 point is the limit as h approaches 0. This is you just need to memorize this. This is possibly the most important little equation or thing we have all year long. Oops, I didn't leave myself enough room here. Darn it. I always forget that part. F prime of A equals. That's the derivative, right? And again, I'll put this in red. I think it's valid for you to think about this. This part is slope between 2 points that are h units apart. A and A plus h are the 2 points. A and A plus h. And then this part lets the 2 points become 1 point. That's the 2 point. The limit piece of it lets the 2 points become 1. And that's how we get slope at 1 point. And it comes right back to what we did with this document here. Okay, when you think about it, it's nothing more than that little formula that I put in right there, but instead of putting 0.001, we put h, right? The h is like the 0.001. So on your homework, they're going to ask you to do a couple different things. There's going to be some problems where they're going to literally just want you to do a slope between 2 really close points. They may give you a table of values like we started today, Emily. They'll give you a table. You'll grab 2 and 2.05 and you just do a slope calculation, right? So you're going to have some parts of your homework. Or they may say let h equal 0.001. Well, what they're saying is there you got 2 really close points, right? If you're going to do the derivative at 2 and they tell you to let h be 0.001, they're saying do the slope between 2 and 2.001, right? So there's going to be some of that. 2 really close points. And then there's going to be some of this. When it says find f prime of 2 or f prime of 4 or f prime of 6, of course, then that a would change to a 4 or a 6. If they say that by the definition, then they're talking about doing it out like we did here and here. Okay? And there's a few of those in the homework where you have to do that. Okay? By the definition, you work it out that way. So that's basically what your homework assignment is. Here's the new sheet. Okay, it's that top line. 2.1. Okay. I mean, there's going to be some other questions about just, your understanding of this, but the basic elements of this homework is going to be calculating some slopes between 2 close points, where you literally just do the calculation, and then there's going to be some where you do it by the definition, where they're not 2 close points, it's really 1 point. When you do this definition, you're actually finding the slope at that 1 point, because at the end, that h becomes 0. Okay?